Hey everyone, good morning. I'm Priyanshu Agarwal and welcome back to my YouTube channel. Now we are going to see today's Leetcode daily challenge, which is minimum domino rotations for equal low. Okay, so let's see what is this question and how we can solve it. So in this question, you are given in a row of dominoes, top side and bottom side represent the top and bottom halves of the ith domino. Okay, and what is a domino? A domino is a tile with two numbers from 1 to 6, one on each half of the tile. Okay, so you can consider domino something like a dice which have numbers from 1 to 6. Okay, and we may rotate the ith domino so that top side and bottom side swap their values. Okay, and you need to return the minimum number of rotations so that all the values in the top side are same or all the values in the bottoms are same. And if it can't be done, then you need to return -1. Okay, so let's see. So in this question you have been given that you have a domino which have some value on the top and the bottom, which is represented in the form of two vectors, tops and bottoms. Okay, and you need to return the minimum number of swaps, and you can swap their values. Let's say if top has 2 and bottom has 5 value, then you can swap their values, then it will become 5 and 2. Okay, so you need to return the minimum number of operations. It means minimum number of swapping you need to do to make either all the values of the top equal or all the values of the bottom equal. Okay, so let's see how we can solve it, and if it can't be done, then you need to return -1. Okay, so let's see. You have been given that top array 2 1 2 4 2 2 and a bottom array which is 5 2 6 2 3 2. Cool. Now you need to check if you can make all the values of the top equal or all the values in the bottom equal. Okay, so let's see. So what can be the values of the top or what can be the values of the bottom? 2 can be the value in all the places of the top and in all the places of the bottom, right? Because we can swap their values. And 5 can be the values in all the places of the top and in all the places of the bottom, right? Can there be any other possibility? No, because only 2 and 5 can swap their values. So either 2 can be present in all the places in the tops and or bottom, or 5 can be present in all the places of top and bottom. There is no other value, there is no other possibility which can be there in all the places of the tops and bottom. Okay, so it means we just need to check for top 0 and bottom 0 whether they can be present in all the places either in top or bottom. Okay, so let's see. So let's say we have two target values, that is 2 and 5. So let's say initially our target is 2. Cool. Now what we can do, we can create a function to check the number of operations needed to make all the values equal to 2 in the top and the number of operations needed to make all the values equal to 2 in the bottom. And whosoever is minimum in these, then we will return that one. Similarly for 5, we will check the number of operations needed to make all the values equal to 5 in tops and number of operations needed to make all the values equal to 5 in bottom, and we will return the minimum of them. Okay, so let's start checking for target is equals to 2. Now what we can do, we can simply start iterating in the tops array till tops dot size. Cool. Okay, okay, now we will check. Now we will also initialize our two variables. We can say rotate top and rotate bottom. Let me just write it as r top and r bottom, which is r top is the number of operations needed to make that value equal to 2 in the top vector, and r bottom is the number of operations needed to make that value equal to 2 in the bottom array. Okay, so initially both of them are 0. Okay, now we will check whether any one of them from tops of I or bottom of I are equal to target or not. because if not, then we can't make all those elements equal to target, then we will return -1. If yes, yes, in this case, yes, they are equal to 2. So first condition will be if tops of I is not equals to target and bottom of I is also not equals to target, then we will return -1, because then we can't make these elements equal to target. Okay, otherwise we will check if tops of I is not equals to target. No, it is equal to target, then it's fine. We will check if bottom of I is not equals to target. Yeah, it is not equals to target. It means we might need to swap these values to make bottom values as 2. So what we will do, we will simply update our rotate bottom by 1, because to make the values equal to 2 in the bottom, we will need to perform this one operation. So what it will become, if bottom of I is not equals to target, it means what we will do, we will simply update our rotate bottom. Okay, now let's come to another index, which is this. Now we will again check whether both any one of them are equal to target. Yes, so we will move forward. Whether tops of I is equals to target or not. No, it is not equals to target. So what we will do, we will simply update our R of top, rotate of top. Top of I is not equals to target, then we will simply update our R of top, right? Because we need to swap these values to make all the elements equal to 2 in the top vector. Okay, now we will check for bottom of I. Yeah, they are equal to target, so we will just continue moving. Now let's check for next index whether any one of them are equal to target. Yes. Now let's check whether tops of I equals to target. Yes. Whether bottom of I equals to target. No. It means we need to swap these values, so we will update it by 1. Now let's check for another index whether any one of them are equals to target. Yes. Now whether tops of I equals to target. No. So we will need to update it. Whether bottom of I equals to target. Yes. Cool. Now let's check for another index whether any one of them is equals to target. Yes. Whether tops of I equals to target. No. Yes, yes. So we will just continue. Whether bottom of I equals to target. No. So we will update it. Now we will check for another index whether any one of them is equals to target. Yes. Whether tops of I equals to target. Yes. Whether bottom of I equals to target. Yes. So finally, by the end of this loop, our rotate top and rotate bottom values are 2 and 3. And now we will simply return the minimum of these values, which is 2, and which is going to be our answer. You can see in this case, right? So what we have done is, we have two targets, tops of 0 and bottoms of 0. We will check for tops of 0 first in this way, right? And if it is possible to make all the elements either in top or in bottom equals to tops of 0, then we will simply return the minimum of them. Otherwise, if it is not possible, then we will check for bottoms of I in the same way. The logic will remain same, just the target value will get changed. Cool. Now let's just check for another example as well, in which it is not possible to make all the values equals to, all the values are as equal in either in tops or bottom. Okay, so let's check for that example as well. 3 5 1 2 3, 3 5 1 2 3, and 3 6 3 3 4. Bottom is 3 6 3 3 4. Cool. Now what can be our target values? In this case, our target is same. It means tops of 0 and tops of bottom of 0 is same, so our target value is 3. Okay. Now what we will do, we will start checking. We will initialize two variables, we can say rotate top and rotate bottom. Okay, now we will check whether any one of them is equals to target. Yes. Whether top of I equals to target. Yes. Bottom of I equals to target. Yes. So we will just keep them as 0. Okay, now let's check for another index whether any one of them is equals to target. No. It means we can't make any one of them equals to 3. It means we can't make all the values neither in top nor in bottom as equal. So it means what we will do, we will simply return -1. And which condition will return -1? This one. in which neither tops of I equals to target, neither bottom of I equals to target. So we will simply return minus 1, right? Okay, now let's try code this. Code is going to be quite similar as the pseudocode which I have shown you. Okay, now we will initialize a result and we will implement one function check which we take as target, which will be tops of 0 and tops and bottoms. If it will not return -1, it means we have got our answer. So we will simply return result. If it return -1, then what we will do, we will simply check for another target which is bottoms of 0 and with tops and bottoms. Good. Now let's implement this check function. Check int target vector int tops comma vector int bottoms. And what we need to do, we need to initialize two variables, rotate top, rotate bottom with 0, and we will start iterating in our tops vector. I is less than tops dot size, not tops vector, like take the size of the tops vector. We need to check for both tops and bottoms. If tops of I is not equals to target and bottoms of I is not equals to target, it means we will return -1. If tops of I is not equals to target, it means we will need to swap its value. It means rotate top will get incremented. If bottoms of I is not equals to target, it means we need to swap the value for bottom. So we will update our rotate bottom and we will finally return minimum of rotate top and rotate bottom. Cool. Let's try run this. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexity. So as you can see, we are just doing a single iteration in this approach. So its time complexity is going to be big of n. And as we have not used any extra space, so its space complexity is going to be big of 1. So yeah, this was all for this question. I hope you get it. But if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys. See you in the next video.